Okay, let's make a formula for kinetic energy and then calculate kinetic energy. So here, if you notice, for potential energy, I exerted a force, and the force was specifically for lifting something up, yes? We were changing the position of this box. For kinetic energy, it's not so much that we're lifting it, it's that we're going to speed up the object, right? The force is now going to speed the object up. So imagine some object on a frictionless surface, right? So here's this object, and we push on it for some distance d, right? And it starts off with an initial velocity of 0, and at the end of that distance, it starts with an initial velocity of 0. At the end of that distance, it's actually moving with some final velocity v, right? And we exerted a force of F to cause this to happen, right? And so to figure out the energy we've stored in this thing, we say work is F times S, yeah? Okay. And then instead of S, I'm gonna substitute D. Okay, and then instead of F, I'm going to substitute MA. Is everybody okay with this? Because I really don't want to go on unless you're just right on the same page with me. Is everybody okay with that? Okay, good. Because I wouldn't want anybody to get mad. And there really is no other reason. I think that's funny, right? There's no other reason to use a D here except for that, you know. I'm going to have to go back and call it S again, you know. Okay. I know what you're saying, though, you know. If I put an S in there, then you have to say no mas, you know. Okay. And now we've got this problem, and here's the problem. I know intuitively in your head, you are thinking to yourself, A and D can't be in there. And the reason they can't be in there is that all that matters is what? If a baseball flies in this room and hits me in the head, okay, how much energy it has depends, does it depend on how much distance we took and the acceleration it had speeding up? Does that matter? Or is it just the mass of this object and the velocity that matters? Just the mass and the velocity. Somehow we've got to get rid of A and D and get the velocity, right? So how are we going to do this? I think the thing to do is let's use the v squared formula. V squared is u squared plus 2as, right? If the initial velocity is 0, then A is just v squared over 2s, right? So A is v squared over 2s, and because I had to make a stupid joke, now I have to say that it's v squared over 2d, yeah? Right, and now I can substitute that in for A, and I think everybody will be happy, okay? We go, is everybody okay with that one before we do it? Because I wouldn't want you to be squared. That one's not as funny. First one was a real knee slapper with that one. What cancels then? We got rid of A, but we also got rid of D. Yeah, so this is also not history dependent. If that baseball were somehow accelerated, if it were accelerated by a quick snap in like a meter, right? Or if it was accelerated somehow by some clever mechanism that took 100 meters to get it up to, 90 miles per hour. If they were both going 90 miles per hour, they both hurt as much. Doesn't matter how it gets to that speed, right? Nobody writes it this way. Everybody writes it this way. I think in our data packet we write it E sub K. Almost everybody else in the world, by the way, says KE. They call that one PE. I'm just writing it the way it's in your data packet, the way IBI will give it to you. So it's 1/2 m v squared, like that. There it is, right? So this is our kinetic energy in joules. Right? This is our mass in kilograms. Velocity in. Yeah. And then, of course, this leads to the whole driver's ed thing. Look at that formula. What happens if we double the velocity of the car? What happens to the kinetic energy it's got? Yeah, if you double something that's squared, well, 2 squared is 4 times, right? It's a parabola, right? So your kinetic energy, the more velocity you get, the more destructive power your car has, right? This is the rationale behind the M16, which is a relatively small bullet that the U.S. military uses. The idea is that it's a very high velocity round, right? And so we get the ability to harm things by velocity, not through mass. And then the soldiers have less mass to carry around for ammunition. Okay. The only problem with high velocity rounds is that air friction is also huge, right? And so if you hit something with these rounds, like a piece of like a twig or something like that, the bullet often goes off course and is very inaccurate. So it's not so good for shooting through brush and stuff like that, as they discovered in the Vietnam War. Heavier, slower bullets were better for that. It is why, ostensibly, in the movie Billy Jack, or when people fight, do martial arts, they take their shoes off, right? The shoes give you more mass, but it's the velocity that counts. And also, if your foot is moving slower, it's a lot easier to block, right? That's another thing that's going on there. And then just be very careful of this. Although this one said change in potential energy, change in height, and that works. You cannot do the same thing with kinetic energy. Okay, let me show you what I mean by this. You can't find change in potential energy by using change in velocity. Let's suppose you have a 5 kilogram mass, and it goes from 2 meters per second to 7 meters per second. Okay, how much work did we have to do that, or how much energy change did it have? You cannot go 1/2 m times the difference squared. That doesn't work. Okay, let me show you why. This is sort of a basic math thing. Unless I pick numbers where it does work, you know. But in general, it doesn't work, right? So this initial kinetic energy is 1/2 5 times 2 squared, right? 2 squared is 4. Half of 4 is 2, and 5 times 2 is 10 joules, right? Right? And then this energy here is 1/2 5 times 7 squared. I'm just going to use a calculator for that one. 0.5 times 5 times 7 squared. This is 122.5. Right? What people are tempted to do, and this just doesn't work, is they're tempted to say, well, this change in potential energy is 1/2 5 times, well, what's the difference here? 5 squared, right? This doesn't work. Let me just convince you of this. Times 5 times 5 squared. 62.5. Is that the difference between these two? No, it just doesn't work. Why doesn't that work?
That's 5 squared.
Because there's some principle here, isn't there? Some principle that 7 minus 2 squared does not equal 7 squared minus 2 squared, right? That's like a basic math thing that they have to like unlearn. People think, oh, it's the same. No, it's not the same thing. Okay? This definitely does not equal, right? Let's have you guys try. There are 2 ways to speed up the math. Right? The first way is the second way is doodly 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 doodly. There we go. Doodly 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 doodly. Oh, I was still recording.